2 summers ago, I actually interned for a shipping company because I wanted to see what I can do in the corporate world. Not to get hired, I just want to hone my computer programming skills. And I made some computer app tracking the international bunker fuel prices. So some of you who are an MT major might understand what I'm saying. See, for a lot of shipping companies, bunker fuel prices is directly related to their profit. So being able to predict whether the fuel price is going to go up or down, that's pretty important. When you have a function, what you really want to know often is it increasing? Is it decreasing? How fast is it increasing? How fast is it decreasing? Okay. These are called average rate of change. So let me give you an example. Start with a simple function as an example. Let's say you have f of x equal to x squared. The question is, A, what is the average rate of change from x equals to 2 to x equals to 5? Okay. And B is the function on the average increasing or decreasing in this interval. Let's try to answer these questions. And actually the second question, you don't really need to calculate the first one to answer because we already learned that the graph of y equal to x squared looks like that, right? So here's 2 and there's 5 way up there. So if you look at the graph, of course it's increasing, right? It's always increasing. So part B is a very simple question. You don't need the average rate of change. So let's think about the average rate of change. Average rate of change is the following concept. If the slope is very high, do you have a big average rate or small average rate? What's the rate? High rate, okay? If the stock market prices are moving like this, oh, then people are very busy. They have to figure out whether to change their position on the options and sell or buy or hold, whatever. Okay, so but then on slow days, the rate of change is small. That means it's almost close to flat line, like 0. Okay, but after what I just explained, you should directly see the relationship between the rate of change and the slope, right? So when I say, what is the rate of change from x equals to 2 to x equal to 5, you're really trying to figure out the following. You have this graph from 2 to 5, and you want to know this slope. That's the question. Now, what's the formula for the slope? Change of y over change of x. Very important. After this class, you'll be going into Calculus 1, and yeah, some of you don't have to take Calculus 1. Yeah, you might be very glad. Yeah, but most of you will take Calculus 1, and over there, this rate of change of y over change of x, is the central concept there. Okay. All right. Also, if there's any business major here, in business, like knowing this rate of change is very, very important in economics. Yeah, macroeconomics and micro, they think about this a lot. Okay? All right, so you have change of y over change of x, and that means I need to know the y values. Okay, so for this input 2, what's the y value? 4, because if you plug in 2, 2 squared is 4. For the input 5, what do you get? 25. Now, how do you get the change of quantity? It's terminal minus initial. So if you want the slope from here to there, it's terminal minus initial. And you're trying to put the change of y on top. I noticed that some of you got this backwards on the exam. All right, change of y should be on the top. So it's 25 minus 4 over 5 minus 2, because it's from 2 to 5, so you have to do 5 minus 2. Okay? It's always terminal values minus initial. All right, that gives you 21 over 3, which is 7. So 7 is the rate of change. In other words, on the average, as you move from 2 to 5, every increase of 1 for x will bring about 7 increase in y. That's what this means. Right? That's the average rate of change. Now, if this average rate of change is positive, is the function increasing or decreasing? Increasing. Okay. If that's negative, what do you think? Negative slope means this, right? So that means the function is decreasing. Okay. So that's how it's related to the second one. Now, I want to show you the formula for this now. So in general, we can change that into a formula. The formula itself looks very ugly, but you know, if you understand what we just did, it's kind of obvious, right? Okay, so let's say you have y equals to f of x. The rate of change from x equal to x1 to x equal to x2 is, let's try to write down this formula, is change of y over change of x. This is a mathematical fact. That's not going to change. Okay, so we will always be calculating this. And now what's change of y? Well, it's the y values. But I'm only given x values. How do you get the y values? What do? You have the x values, x1 and x2. How do you get the y value? You just plug it in. If you plug in the x value, you get the y value, right? So if you plug in x1 into the function, that's your y value, right? If you plug in, oh, sorry. I should be plugging in x2 first. Yeah, because it's terminal minus initial, so you have to plug this in first. And then you plug in x1 into f. So that's your initial y value. That's your terminal y value. And you do terminal minus initial. Final value minus the initial value gives you the change of y. Now, what would you divide by? Try to complete this. What do you put in the denominator? No, y is on top. x2 minus x1. The bottom is change of x. Okay? So that's the formula for the average rate of change. And don't try to memorize this. The only thing that you should memorize is this, change of y over change of x. Okay? And then try to make sense out of this formula, then it will just feel natural. Okay? If you did make sense out of it, then you can I'm allowing you to memorize it. But it won't be that hard to memorize once you understand it.